So a bit earlier we touched on emerging technologies around EVs. So I guess this question does seem to be going backwards a bit, but how do you ensure that the wiring rules are the most up-to-date they can be when they get published, considering all of the emerging technologies? And this is an industry built on technology. So how do you make sure that it is relevant when it's published?
Whenever you do a revision, it's a massive project. And like 5 years, we're going to be pushing it to do that, but we're going to have to look at it. So you can't always say that it may be the latest information, but what we do is we have a really close connection to the IEC, so the International Electrical Commission, who create all the standards, and they tend to be a little bit further in front on that stuff. So we have a lot of contact with them about emerging technologies and what's going on, energy efficiency and risk mitigation and stuff. The other thing is that just through our work and what everyone does, we do a little bit of, every day we do mining through social media, what's going on in the world. There's some really strange power generation going on at the moment, which is in the US, which is converting electricity into data, zeros and ones, and then sending it for 2 kilometres through data and then reconverting it to electrical power. So those are the things that we're trying to keep ahead of, just as I guess the normal person, how they can do that. And IEC gives us a lot of leads about where things are changing. So everything we do is it's a fair crack at making sure it's the most up to date, but we certainly can't be.
And the IEC 60364 series of standards is the international standard for wiring rules, and we try to keep up to date with the work that they're doing. Although that's a very big topic, there's papers coming out all the time there.
Also the cross-representation between committees, so we're on various other committees besides wiring rules. We're on product standards committees. The organisations for which we work have representatives on IEC. So at least from the manufacturer's perspective, we've got a pretty good insight into what's going on with products that are coming down the road at us. That certainly helps stay ahead.
So what are some of those emerging technologies then? Do you think
the power over Ethernet is a huge one. At the moment in data cabling, there's another, again, they've created a series of classifications for that cabling, and can't recall the terminologies at the moment, but basically they start off at a very small amperage that they're actually switching, so they can switch using data cables. I think 0.75 milliamps or something they're working on. But then there's another category that moves up to 2 amps, and then there's another category, I think it's 5 amp. Then above that there's 10 amp and above that they're talking about switching through data cabling, not through power cabling. So that is a bit scary because all of a sudden you've got that 250 volt potential in your data cabling. So those are the things that I see that is going to change what we do. I think there's a lot of devices now in the home that can be run off of data cabling, powered up. So that's a big change that I see.
And there's also the potential for DC buses being used, because solar generation is DC and then it has to be converted to AC, so it'll be interesting to see how that pans out as well.
You can run things off the DC, you can improve the efficiency by taking out the rectification, all those other things that contribute to losses.
And LEDs generally don't require more than 30 volts to run, so why not have a 30 volt DC supply, and you can take out all that conversion from DC to AC and back to DC. So there are efficiencies, and that's a big topic that Gary and I were talking about, is the efficiency in the installation that is being looked at now. That the size of cabling was generally just looked at because of what's the heating effect. But now, if you look especially on electric vehicle charging, when you've got heavy loads constantly being used, that it can actually be cost effective and save energy by running oversized cables and getting a lower voltage drop and saving that power loss in the cable, which generally wasn't considered before, but now it can be significant. So you're changing the design. So instead of using 1.5 square millimetre cable, you may use 4 square millimetre cable, and you'll save that energy that's lost in the resistive losses in those cables, and you can save the cost of the cable can be saved in energy cost, because energy is much more expensive now than it was.